Good morning, everyone. This is Bruno Dupuis from FAMIC Technologies. I'd like to start off by thanking everybody for attending this first webinar of our series in Automation Studio version 8.0. I see more and more people are joining, so we'll continue as scheduled. So here's a list of the 5 webinars included in the series. So the first one that we'll be going through today is on the hydraulic manifold developments. Our webinars that we're going to have are going to be every Tuesday, same time every week. So you can connect to those based on the ones of interest. You also need to register to each webinar separately. So whichever one you register to, you'll be able to attend. And also, we'll be sharing the webinar videos as well with all registered participants. They will be placed on our website in due time. So here's a little overview of the agenda today. So my colleague Nikolaos is going to be going through this a little bit more in detail during the presentations, but primarily we'll be focusing on some of the recent developments made on Automation Studio version 8.0, so including some of the machining parameters, some Excel block calculations, some information on the 3D layout, technical production drawings, and also generic catalog and web catalog manifold components. We will be reserving at the end of the webinar, maybe about 15 minutes, 10 to 15 minutes, all depending on the time of the webinar, some questions and answers. So feel free to send us your questions. You'll be able to use some of the tools in GoToWebinar. So there is, you should see this questions panel that's available for all attendees. So what you can do is if you want to ask a question, you can do that anytime during the presentation. It's preferable that you use that tool instead of raising your hand. Since there's so many people connecting, it's easier for us to just answer the questions as they come up. And then based on some of the interesting questions that we have here, we'll be able to maybe recap on them a little bit during the questions and answers period at the end of the webinar. So thanks again for everybody for joining. So without further ado, I'll pass things over to my colleague Nikolaos so that we can get started with today's presentation contents. I hope you guys enjoy the webinar for today.
Welcome to this presentation on what's new in the Manifold workshop in the newest version of Automation Studio 8.0. To begin, I'll give a brief introduction on what we'll be going over today. So we will be looking at some new features that were added in regards to the machining parameters, new features regarding a new Excel block cost calculation system. So this is an export to Excel of the machining parameters within which the users can create their own formulas and calculate the cost of their block. Some new 3D layout features as well. New features for the technical and production drawings. Some new components that we have in our generic manifold elements catalog, as well as the use of the web catalog for the creation of manifold blocks. So there will now be compatible, the web catalog will now be compatible with the manifold workshop. And we'll finish with a Q&A session where you can ask through the chat. So you can just leave a question in the text box in GoToWebinar, and we'll get to those questions at the end. To begin with, we'll be going over the machining parameters. So if we take a look at what's been added in these images below, you can see for on the left, we have our production drawing, and we have callouts that display the machining information for the different holes. We also have on the right image, the machining parameters displayed in a table. So for each face of the block, you will have different holes. So A1, A2, for example, in that image, for representing the holes on the top face, as well as an export into an XML format. So you have an export for CAM. We have a MasterCam plugin that is under development, and we will be working after that on other plugins for different software, other CAM software. So I'll head into Automation Studio, and we'll begin with creating a simple circuit that we'll use to demonstrate all of these new features in the newest version of Automation Studio. So as always, when creating a manifold, you have your manifold commands in the Fluid tab that I can use to access uh, my catalog manager. My Automation Studio Manifold Elements catalog is open. And what I'll do from now is I'll insert some components that we'll be seeing that are new. So we have now a generic orifice plug uh, in this catalog. So it's widely requested by users. And you can see if I click on the configuration button, we have different sizes that are available from different standards. So metric, NPT. I'll be leaving it as a 1/16th NPT orifice plug just for this case. I'll give it a special part number. Uh, uh, Let me just go ORF in this case, something like that. Uh, and I'll insert that onto my schematic to use. And I'll also go take some, I have a Hydroforce catalog open. I'm going to take some components from this catalog. So four-way two-position directional solenoid valve and direct acting relief valve. I'll just go and place those on my schematic and then I can close that. And we'll use these components to create our block. So the first thing I'll do is I'll double click and just go set a configuration for these components. I'll pick the first option in each of their properties. So I'll just go select, I'll put a coil, and then I'll select, have a configuration. I'll do the same for the relief valve. And then I'll just finish up my manifold block. So position this, something like that, and I'll place my boundary line. Here we go. I'll do something like this. And I'll go and position this over here. I'll select all my components, generate my manifold circuit, and then open the manifold workshop, which is opening on my second monitor. So we'll wait for that, and then I'll drag it over. So now that my manifold workshop is open, I'll start by auto creating my block. And then once my block is created, we'll take a look at the new machining parameters that we can see in our Project Explorer at the top. We have this new machining parameters tab, and we'll be able to take a look at what that entails. So I have a manifold that's been created here. And now I can go take a look at my machining parameters for this manifold. And you can see that I have a document that's divided into different sections depending on the faces of the block. So top face at the top, then front, back, left, right. And in each of these sections, I have the different hole names. So A1, A2, as defined in the project properties. You can see you have an item identifier, so a drilling name, a plug name for what's been used, some coordinates, diameter for the drilling, for example, the depth of the drilling, uh, the machining parameters information, so the expander that's used, the machining type, so if it's a form tool, for example, for the type of cavity, uh, the vertical, this is a vertical cavity port connection, for example, uh, and you have different information, for example, for engravings. I can see my relief valve over here, what cavity it's using. It's a VC08-2 variation B cavity. I see my orifice plug over here, 1/16 NPT, uh, and some more engravings for my ports at the bottom here. In addition to that, I could go to my production drawing, where I can auto-create my drawing. And we'll see that after that, I'll be able to use the drop-down list to add my my machining callouts automatically. You can also head into the current drawing options and have that function be added when you click on auto create by default. Uh, in this case, it's not there by default, so I'll go into the drop-down list and I'll click on machining callouts. So I have, you can see a bunch of different callouts that are added to my drawing that I can move to position as I want. I can align them with other callouts on my drawing. Uh, Something interesting to note is that if I go back to my 3D manifold layout and I do something like go onto a specific face and add mounting holes, let's see which would be the best face to add these on. This is fine over here. So I'll go and I'll add a mounting hole over here, or just position them here. And since they have the same diameter, what we'll see is when I head to my production drawing, and if I regenerate my machining callouts, I'll have a representative callout. So you can see over here, a representative callout for my two holes, my two mounting holes. Let's position this like that. And what I can do is I can right click. I can see that there's a representative callout currently used for B1. I can switch it to B2 if you want to change where it's pointing. I can also remove the representative callout. So now I have two lines, and this is the two are now grouped instead of being representative. And then I can also remove the callout from the group. So I'll have two separate dimensions for each hole. If I want to regroup them, all I have to do is simply drag and drop one over the other. You see this purple box appear. And then if I want to remake it into a representative callout, I can just right click, create representative callout, and say I want it to be positioned on B1. So this is a new feature for the production drawing. You have a much more information that's displayed on this drawing now. In addition to that, like I said, we have the import-export 3D layout to CAM. So this is a .prx CAM file. It's an XML file, which will that you can export all the production, the machining parameters to, and eventually it will be used as well with the plugins that will be created for Mastercam, for example. Uh, next, what we have is the block cost calculation system that's been added. So there's a new export feature where you can export all your machining parameter information to an Excel file, as you see in the images. So what I'll do is I'll go and show you the option there where it's configured. So if I click on the Automation Studio logo in the top left, I have a preference button and I have the price parameters. At the top section, we have the old system, which still works perfectly fine, which is the database. For example, you can open in a software like SQLite Studio, uh, and you can add your component pricing. Uh, but we have a lot more flexibility now with the price calculation via Excel formulas. So I've configured uh, in my Automation Studio folder, in the AS Live Manifolds subfolder, we have Excel files. So we have an Excel cost parameters template, and we also have an Excel cost parameters template formulas example with formula examples. So this is the one that I've selected uh, over here. So once I click on Excel price calculation, it'll begin to open up my Excel file. And what we'll see is the export of all of our machining parameters, our project parameters, our part list, and the use of that to calculate a block cost. So if I just click on Excel price calculation, it'll begin opening the Excel file. So we'll just wait for that. So now my Excel file is open. It opens to this cost formula examples page. So you can see here I have pricing for my different components. So my plugs, my two valves, my orifice plug. I have a price for my different materials. So currently we can see that aluminum is selected for this project. That's what was by default in our project parameters document. I have different prices for the different machining operations, so cutting costs, surfacing costs, based on some generic formulas. If you want your own prices, you will have to modify these formulas or create your own formulas. Uh, so tool costs, tool change costs, engraving costs, surface treatment costs, all information that I've added. Uh, Costs for creating for drilling the cavities, and for the different drillings in the block, tapping information costs as well. You can see that we have the first 5 documents here uh, are will contain information exported from our project. So we have our project parameters. So we have our block size, our material finish. Uh, we have our part list as well. So our different components, their part numbers, machining information, so information on all of the holes in the block. Uh, this is the table that we're going to be referencing the most in the formulas that we've added. Then you have also the diagram. You have your manifold block, so the current view that you're displaying in your 3D. And then your cost formula examples, and you can see like how we can change the pricing. So for example, if I was in my project parameters and I didn't have aluminum selected and I had, for example, uh, ductile iron, I can just copy this and we'll see that the price difference, instead of being 2.45, if I go to my project parameters and set, instead of aluminum, ductile iron, I have 1.23. So uh, a reduced price for the ductile iron in comparison with the aluminum. Uh, so now I can just go and we can check out our 3D layout functions that are new. So you can see in this this page here that we have some new features with respect to spot face and counterbore. We had some users that requested that we have the ability to remove the spot face whenever we add a counterbore, so that it won't appear, for example, in the machining parameters, or they don't want to have that spot face there. So we've added this option in the counterbore options for a specific component cavity, that you can now remove the spot face. You have the ability to display cavity threads. So this information has been added for most cavities in the cavity database. You also have the ability to see the routing status directly in the Automation Studio interface status bar. So you can tell very quickly the status of your block, if it's completely routed, if you're missing some connections. The ability to modify the sorting parameters when you auto create a block. So I'll be taking a look at that as well. Dynamic dimensioning. So when you're manually modifying your block, you have more control over the positioning of your components uh, with respect to the origin of the block and the sides of the block, and with respect to other components on the block as well. Then you have the depth of a buried component can be modified. So this will apply to components like the orifice plug. You will have a specific menu where you can go and change that, or you can just drag on the 3D as well. You have cavity rotation axes that have been added to all cavities, basically. So when you select a component, you'll be able to see its cavity rotation axis. And we have new plug standards and sizes that have been added as well. So I'll just go into the 3D and we can take a look at all this. So on this 3D, the first thing that we can take a look at is the spot face versus counterbore. So one thing I can do is I can go, for example, and look at this port, for example, which has a spot face, and I can add a specific counterbore to it. So you can see you have this spot face section that's still there. I'm just going to go and remove my dynamic measurements for the moment. And what I can do is I can make this more obvious. Just if I go in my counterboring and I just increase the diameter slightly to 32, you can see the counterbore is it's separate from the spot face. But let's say I didn't want that spot face there anymore. I didn't want this specific diameter. I can just right click, enter my counterboring menu, or I can do it through the design tab counterboring. And I can see that I can remove the spot face. It only available if a counterbore exists. In this case, it does. And we'll see this specific section disappear. And now we have our port with a counterbore without that spot face. So that is gone. You can also see that we have our cavity threads displayed for these ports for our specific valve, our solenoid valve. If I go to the View tab, I can toggle the thread on and off if you don't want to see it. I also have the status of my block in the toolbar here at the bottom, the status bar at the bottom, so I can see all bindings resolved. If I click on it, it opens my channel visibility window. So I can see the channel visibility over here, and I can see the status of all my channels in the block. I can select them. This channel visibility window already existed, but we have easier access to it through the status bar at any moment in time. We also have the ability to access our routing solution. So if I access my routing solutions either through this command here or through the status bar, it opens on my other window. I have all my solutions that are sorted according to my sorting options. So if I click on the sorting parameter settings here, I can see that what I have for my sorting parameters is I have two fixed parameters that I can't change their position, which is the least amount of errors, and the least missing bindings, which is the least missing drillings in the block. So those we always want to be our top priority. And then you have a few other options that you can select for. So let's say I wanted the least number of drillings as my top options instead of the smallest dimensions, which you can see here for the volume. We have the lowest volume as our first solution. In this case, I have, let's see if we have any solutions with less drillings than 8. So I'll click OK. And then if I sort my block, you can see, oh yes, I have solutions with 7 drillings. So if you want, you can sort your solutions like that. You have other options. So faces with connection ports only, respecting the preferred faces, etc., as options as well. The next thing that we'll take a look at is the dynamic dimensioning. So you see the dynamic measurements that I've turned off. I can select those to turn them on. And when I select a specific component, for example, this mounting hole, I can see its position with respect to every face on the block. So let's say I wanted it to be at 40 here. a distance of 40 millimeters from this block surface. I can do that. I enter 40, I click enter, and you can see the position is adjusted. Now I'm not respecting my options that I've set, so my clearance isn't enough. You can see that if I highlight it in the tooltip, there's a current clearance, does not respect the current drilling clearance rule. So we can see that I can go back and adjust it to 42 once again. So you can see I can position with respect to the faces, but what I can do is I can also position components with respect to each other. So if I right click on this component and set it as a reference used for dynamic measurements, when I select other components, you can see I have its position. I have this component's position with respect to my reference component. So I can see that it's positioned at vertically a distance of 20 below it and 35 to the right of it. And the same goes for my mounting hole. So I can see if I start moving it, I can see its position at 32 and 19. So I can go back to, for example, a 0, so I can have it aligned correctly over here. I can do that, and if I go back here and I'll put it at like 18, that's still not good. We'll go to 17. We're still in a different slightly, so let's go somewhere there. There we go. And now we can, you see, we can position our components using these dynamic measurements. As always, you can always right click and click set location to have the component coordinates on its specific face. And if you want to see what Y and Z are, you can always toggle the reference axis in order to see your origin and your reference axis. You can modify that position just by right clicking and change the reference axis to the nearest corner that you've selected if you wanted to do so. In this case, I'll keep it the same. The next thing that we can take a look at is the depth of a buried component, how we can change that. So we saw when I created my my block, I added this orifice plug, an NPT orifice plug, so you can see there's a taper to it. I can modify its depth either by, let me just, first thing I'll do is I'll go and I'll show my resize handles, just increase the spacing of my block here. What I can do is I can go either right click, adjust variable cavity. I can change the depth. You can see it's currently 24.3515. If I activate my dynamic measurements, I can see, 24.35. And I can use this, this blue circle to modify its depth in my block. So, and if I go back to my adjust variable cavity, we can see it's now 47.19 is the current depth of my orifice plug. Next thing we can do is we can take a look at the new features for the technical and production drawings as well. Actually, before we do that, we can take a look at the plugs, one thing that I didn't mention. So we have the new plugs, so different standards for plugs that are available. If I go to my current options, I can select, for example, to use one of my new plugs. So we have NPT plugs, BSPT plugs, JIS, Japanese standard plugs. So let's say I take JIS B0203 plugs, which are tapered plugs. I select those and I'll toggle off my expansion plugs. So we only use these threaded JIS plugs. And I'll click OK. And I'll just simply auto create my block. We'll have a block created using these new GIS standard plugs. So let's just wait. Okay, there we go. We have some solutions created here. And what I'll do is I'll just take the current best solution at this moment, and I'll let it keep searching in the background. So we can see now, if I go onto this front face over here, we have specific plugs that are tapered. So this is the GIS B0203 standard. And we can see that these are the plugs that are now used in our manifold block. Now heading back to the technical and production drawing page here, we can see that we've already taken a look at improved callouts in the automatic sense for the production drawing. We also have the ability now to add some manual callouts on the technical drawing. Uh, so this will use like the GD&T keyboard standard, and we'll take a look at that right now. So if I head back here into my technical drawing, I can go to the design tab, and in the design tab we have this drawing group, and in this group we can see we have the ASME GD&T standard keyboard and different sizes of keyboard that we can select. So small keyboard, medium keyboard, framed, full. And you'll be able to see that if I go and I add a callout, so standard callout, I have the small keyboard that is displayed, for example. So if I wanted to add diameter 20, something like that, I can do that. But if I wanted to show the full keyboard, I can go GD&T full keyboard. I can see the full keyboard that I have available. So I have my symbols, and I also have the symbols framed. I have the numbering. I have decimal points. I have the separators. So what I can do is if I want to add a specific, for example, geometric dimensioning, I can add a frame. I can go and I can even make it easier for myself and add the frames here. I can select geometric tolerancing, add a diameter. We can make it imperial even. I can put 0.25. I can, I'll just close it off here. And then I can even add like datums if I want. So A, B, and then close it. And then I can modify the size of my specific callout. And you can add specific dimensioning information manually in this way. So this is a new feature that was added as well. Next, I can also show that for any line that you insert on a drawing, you have the ability to add an arrow. So if I go and click on this end point here, I can add a specific arrow. I can change its the scale of the arrow. I can also add for the other side a little arrow over here and do that as well. And next, what I can do is we'll take a look at the generic catalog and the web catalog. So we can see that we also have new port standards that have been added. So we saw the plugs before. You will also have new port standards as well. So the same GIS standards as well as additional like flange configurations that you can select. The orifice plug we've seen. So we'll be taking a larger look at the web catalogs and at generic component simulation in our block. So I can go back to my Automation Studio. And what I can do is I can replace my relief valve component with a web catalog component. So I can go and I can just edit my block. I'll do a few things. I'll remove this relief valve. I'll even remove this orifice plug I don't want. And I'll go into my online catalog. So you can see it opens this online catalog web page. If I enter full screen mode, I can go and I'll just take a Hydroforce component. So we're Hydroforce 5.6. I'll retake the same component for my pressure valves, my relief valve. And you can see that I can configure it. I've already configured it here, but you have the configuration options that are available to select. And what I can do is now that my part number is configured, I can just drag and drop onto my schematic and use this component in my manifold block. So I'll go like this, rotate it, flip it, and use it in my block and exit my manifold editing. I'll head here, and now I can auto create my block once again. So I'll click auto create. Yes. So once I get a few solutions, I'll just take the best solution at this time. So I'll just click get current best solution. I have a manifold block uh, that I'm going to use. So you can see here this relief valve. This is a web catalog component. I no longer have to download my local catalogs. I no longer have to, let's say if I needed admin rights to install things on my PC, I no longer have to contact my IT. So it really can save a lot of time to use these web catalogs. You don't have to manage them on a server or anything. Uh, so next thing we can take a look at is, instead of using this web catalog component, we can take a look at how to use custom components in order to embed specific components that are not yet manifold compatible and use them in our manifold block, and even have their properties be used in simulation as well. So in this case, I'm going to access my Fluid tab catalog manager to access my manifold elements catalog. I'll access the generic components, and we'll use this two-way generic component to replace our catalog component relief valve with a generic relief valve. So I'll just go here. I'll close that. I'll position the ports in the correct way so we can see if I go like that. Port 1 with port 1 and port 2 with port 2. I can double click. We can see by default we have a default cavity selected, VC08-2, which is the Hydroforce cavity, but we can change it to any cavity from our manufacturer cavity database, or from a cavity that we've created ourselves by loading a custom cavity library. I can add a specific part number for my component. I'll just call it RV custom for relief valve custom, and I'll just click apply if I wanted to. And then what I can do is, let me just enter edition mode over here, and I'll repaste it. I cut and paste to put it inside my block. I'll delete my relief valve from over here, and I'll position relief valve over here. So we'll see we're going to use this relief valve in our block. I can see if I position it here, it's not compatible. It's highlighted in red because I have my incompatible components option selected. But what I can do is for example, I can cut it, position my valve here. I'll just go and I'll enter the embedding component. If I click on this edit tab, open embedding component, where I can paste my valve. I can rotate it how I want. So I'll just flip it, and then I'll add my ports. So this will be port 1, this will be port 2, and I'll just position them over the valve ports like so. And then I'll just try edit my block and create the connections with the embedding component. And we'll see that we'll be able to have this component in our block. So if I just click that to exit, and then I'll enter my manifold block, I can see that if I auto create, I'll have a block that will be using a generic 3D for this specific component. But if I wanted to, I could go and I can modify the 3D, which I'll show you. If I right click, I'll have a set dimensions option. So I'll just take the current best solution. At this moment, I have my valve over here. See, if I enter a flat view, I can right click, set dimensions. I can modify its diameter, its height, its diameter. So let's say if I modify the height, I can do that. I have the option to use a rectangular envelope. So if it was like a C-top type component, I could modify its position on the cavity. So I can just show you, let's say if I go and I toggle my reference axis, I'll modify its position in the X axis, let's say by 20 millimeters, just to show you. You can do that if you wanted, especially with the rectangular envelope, it's useful. And you can use this relief valve in simulation as well. So it'll use the, the properties of the component that you inserted in the embedding component as well. So this is another option So basically what it lets you do is use any component in Automation Studio inside of a manifold. It no longer has to be in a compatible manufacturer catalog. It can be a component configured by you, the user, or it can be one from a catalog that is not yet compatible with the manifold module. That concludes our webinar topics, and we will now be moving on to the Q&A section.
Great. Thanks so much, Nikolaos. So just a friendly reminder to everybody, if you have any questions that you want to be able to ask, please use the questions box that's available in the GoToWebinar application. So we'll be moving on now to some of the Q&A session for this webinar. So let's see here. Okay, yeah, we have a couple questions. So first question, Nikolaos, you can hear me? Yes.
Yeah, I can hear you.
Great. So the first question is, are the wall thicknesses designed with regards to pressures present?
Yeah, so the wall thicknesses do not take into account the pressures present. It's up to the user to set the clearances in the manifold design options. So you'll have clearances between the block surface and the cavities and the drillings inside the block and the different components that you'll be able to set yourself, and you can configure that for the different materials as well. So you can have different clearances for when you have an aluminum block or for when you have a steel block as well. So
Great.
exactly.
Actually, Nikolaos, I'm going to make you presenter again. If you just want to
Sure.
showcase where those options are in Automation Studio, I think it might be helpful for some people.
Yep. Let me know. Do you see my Automation Studio now?
Yeah, it's working good now.
Okay. Here we go. And I'll show you here. So yeah, like I was saying, in the project parameters, you have the aluminum, for example, that's selected by default, but you have different materials that are available. And what you can do is if you go to your default project options through the Automation Studio logo and preferences, you have the default manifold design options. And in these default manifold design options, you can set for each different material, you can set your clearances. So if you're talking about between the manifold edges and your cavities, for example, and your spot face or counterbores of your cavities, you would set that here. And you can set that for your different materials so that when you select, so that this will be saved on the software side so that whenever you create a new project, it will always take into account the clearances that you've set here. And as always, if you go to the 3D manifold layout and then you check your current options, you can go here and you can see, okay, I have aluminum selected in my project parameters. I can set my clearances for all my clearance options for this material. And this is for my current project. And that will be taken into account when I auto create, or even when I'm manually modifying my block, it'll give me warnings if I'm no longer respecting my settings over here.
Good, thank you. We have maybe another question here. Yeah, it's another question. Is it possible to determine the direction of the inputs and outputs based on the installation space situation, or are these fixed by the optimization?
Yeah, I'm not sure if I understand this question fully, so the user can clarify if I don't answer it correctly. But if they're talking about if they can position, for example, their input ports on a specific face and their output ports on another specific face, then that's definitely possible. What you can do is, and this not only applies to the ports but to all components. Before you click on the auto create button, you can go on a specific face and you can lock that component to the current face. So you'll have this pin that appears to show that, okay, this component is positioned on this current face. And what that'll do is, let's say I want this on this port on this face, and then I want as well let me go here. I don't even know if it's going to give me, if I move this to the opposite face and I say, I also want this component on this specific face as well, this port on this face, and then I auto create, I'll only get solutions where those two ports are on the front face and the other two ports are on the back face. So I'll just wait here and I'll take the first solution that it gives me. But all the solutions that are going to be provided are going to be solutions with those two ports on one face and the other two ports on the opposite face, because I did lock it on the current face. So that's something that's possible to do. And as well, everything, like you know, is based on your schematic. So if you have specific input ports there, you'll be able to see them on your schematic as well. You can highlight your components on your schematic and see that. So you can see my solutions that I generated have the two ports that I pinned to the back face on the back face and the two ports that I pinned to the front face on the front face. And if I go and I click on my routing solutions down here, which opened on my other window, I can see that all the solutions that I have are following those pins that I've set. So that
Great.
should answer that question. Yeah.
Great, thank you so much. We have another question here. This is regarding the Excel export. With respect to export to Excel for pricing, I just want to confirm that this is basically the information that we see on the machining parameters manifold document that is exported to Excel. Can we create our own pricing formulas?
Yeah. So basically, yeah, it's the most important information definitely that's being exported is the machining parameters information. So what you see in this document over here. But you're also getting, in addition to that, you're getting other information exported, such as the block material, the material finish, the dimensions of your block. You'll also have an image of your 3D layout and of your schematic that will be exported as well into that document. And yeah, since it's Excel, basically, what we do, we provide a template. And we also provide we have two Excel files. One is just a template with like the 5 documents, which is the project parameters, the machining parameters. And then we also have a document which contains some example formulas that you can go and you can use that one. And you can even modify that. So if you have your own internal formulas, you can change those formulas to basically use your own. And so it's Excel. You're only limited by what Excel's capabilities are. So you can do anything with the exported information in order to obtain your cost and price.
Very good. We have another question here regarding the machining parameters. Would it be possible to edit the way specific information is displayed in the machining parameters column? So for example, I don't wish to mention, for example, a SAE standard. Can I remove it?
Yeah. So if you're talking about, like, for example, with these ports. So for example, the way that the ports are named in Automation Studio, it'll say SAE8. It'll give the size, and then also you'll have a reference to the standard SAE J1926 at the end. If you don't want to see that, you have the option. We have these what we call machining parameter customization. So if I go here, I can just right click here and I'll copy the selected machining parameters, and I'll go into my machining parameter customization window. And let's say I want to remove all mention of SAE J1926. What I can do is I can just paste what I copied, and I can replace specific text. So I'll replace this SAE J1926 with an empty text. And if I apply, what you'll see is that I'm able to remove that. So now we just have the mention of SAE8 with no mention of the standard as well. And you can do that with basically anything. So I can remove, for example, the same for JIS B0203, or if I don't want to show the spot face text here, I can do the same as well. So yeah, this you can use this to replace text or add text as well through this window.
Good. Okay, let's see if there's other questions here. Okay, yeah, I have one. If I choose to switch over to the web catalogs for my manifold projects, will I still have to keep my own local catalogs for my existing projects? Is there a way to filter the online catalogs for the ones that can be used for manifold?
So for manifold projects created in the past, like let's say using the local catalogs, you will still have to use your local catalogs if you want to continue using those projects. And so in order to access them, because if you don't, you'll only be able to view them in like a read-only mode. So if you want to modify your block, you'll need to keep a hold of those local catalogs, unless you want to go in and replace those components with web catalog components for your projects. Yeah, and in addition to that, for the web catalogs, so if I click on my online catalogs again, and I open up my web page, you can filter for manifold specific catalogs just by clicking on the filter button. You have different filters that are available. If you click on manifold, you can see all the manifold catalogs that are available, and you can select your components directly from here. So,
Good.
yep.
Okay, I think yeah, one more here. Yeah, you mentioned improvements regarding the ability to simulate custom components using the embedded component function. I
Mhm.
would also like to replace 3D models with my own step file in the 3D interface instead of using a generic cylindrical or rectangular shapes. Is that something available?
Yeah, so like, yeah, as I showed before, you have that generic shape that's there. Where if you want to replace it with your own 3D model, that is something that we have developed that will be included in the software version 9. So just know that that's on the way. For the moment, we have these generic shapes, but we will have the ability to a command that you will be able to swap out this generic 3D for your own step file on your block. So that will be in version 9.
Great, thank you. I think that covers the majority of the questions. I don't see any other ones. Some of them were technical issues, but not necessarily questions on the webinar. Okay, well, thank you all so very much for attending this this webinar. As mentioned, the video will be available to all registered participants, and we'll be posting it again on our website in due time. So thank you again all for joining us for today's webinar session. Just here, I'm just going to share my screen really quickly, Nicolas, just to recap on next sessions. So if you can here, just show. Okay, I guess I'm having some. Okay, there you go. Okay, yeah, so just to recap here. So next webinar that we'll have is next Tuesday, February 27th at 9 o'clock. This webinar will be based on the some of the educational and training features available in Automation Studio. So my colleague Chris Chan will be presenting this webinar. So yeah, feel free to register to that one. We hope to see you there. And again, thank you so much for attending this webinar. We hope to see you again soon.